So number 2 from the test review says, given the function f of x equals the square root of square root of negative 2x minus 4 minus 3, list all the transformations which have been made, then list the domain and range. So the first thing you need to remember is that we need to factor out that negative 2. So that's going to be negative 2 parentheses x plus 2 minus 3, like that. So I'm counting 1, 2, 3, 4 transformations. And I'll start over here at the negative 3. That obviously means down 3. This plus 2 means left 2. The 2 means that it's a horizontal. It's horizontal because it's underneath the square root. A horizontal compression by a factor of 1 over 2. Remember that it needs to be 1 over b. That's why it's 1 over 2, not 2. And then finally that negative makes it a horizontal reflection. Now this was a 2-part problem. It says to list the 4 transformations and also list the domain and range. Well, the easiest way to get the domain and range every time is to graph it, but I don't think we need to graph this one because we know what the transformations are. This thing has been shifted to the left 2. Now if you remember that the square root parent function starts at 0, 0, if we go to the left 2, that means the domain is going to be shifted to the left 2. So instead of going from 0 to infinity, it's going to go from negative 2 to infinity. But you also need to realize that it's a horizontal reflection. So this thing kind of looks like this. If we go left 2 and down 3 and reflect it horizontally, if you were to graph this on the calculator, it would look like that. So it's going to go from, the domain's from negative infinity to negative 2. So I'm going to write that real quick. Negative infinity to negative 2. And the range is that's down 3, so that'll be from negative 3 to positive infinity. Negative 3, positive infinity. And that's how you do number 2 there. The next one I want to talk about is number 6, which is a solving problem. I'm just going to zoom in on number 6 there. And we're just solving for x. And the first thing I think we got to do is add 6 to both sides, which will give us 2 times the cube root of x minus 12 equals positive 6. And then I'm going to divide both sides by 2 to get rid of the 2 in the front, to get the cube root of x minus 12 equals 3. Now I'm going to cube both sides. Of course, 3 cubed is 3 times 3 times 3, which is 27. It's going to give me x minus 12 equals 27. And then I'm going to add 12 to both sides to get x equals 39. And you should always double check your answer and make sure you don't end up with an extraneous solution by plugging it in. So 39 minus 12 is 27. The cube root of 27 is 3 times 2 is 6, which equals 6. So yeah, that's right. X equals 39 is the correct solution here. The next one I want to talk about is another solving problem right there, number 8. So I'm going to zoom in on number 8. It's solved for x. You might be inclined to get rid of that 2 by dividing both sides by 2, but that actually doesn't help us very much, because if you divide this side by 2, you still got to divide the 2 over here. What I'm going to suggest you do instead is square both sides. But you need to remember to square the entirety of both sides. So that means you have to square the 2 as well, which is going to make it 4x equals 8x plus 60. And at this point, it becomes an Algebra 1 problem. We'll subtract 8x from both sides to get negative 4x equals 60. Divide by negative 4 to get x equals negative 15. But we need to plug it in to make sure it's right. And when you plug it in, you've got 2 times the square root of negative 15. And then you've got negative 15 times 8 plus 60, which is the square root of negative 60? something like that. But it doesn't matter, because over here when we got 2 times the square root of negative 15, what that means is that these two, they cross, but they cross on the complex plane. Because remember, when you take the square root of a negative number, you end up with a complex number. So on the answer key, you'll see that it says no solution, because this doesn't check. But what it should really say is no real solution, because these two, they do cross, but where they cross is on an imaginary number. So if you were to graph it, you wouldn't actually see it cross on your calculator. So we'll just go ahead and call that no solution, because we got an I when we tried to check it. The next one I'd like to talk about is number 23. And you've probably noticed that there are 2 number 23s. I'd like to talk about the second number 23. It says, it should say extract all roots. Extract all roots and rewrite the radical, the cube root of 125 x to the 7th, y to the 6th in radical form. Now you might be a radical form person, you might be an exponential form person. I am a radical form person. I'm gonna do this in radical form. And when you're doing this in radical form, what you're trying to do is break up these exponent into multiples of 3, because an exponent of 3 and a cube root will always cancel each other out. So I'm going to break this up into the cube root of 125 times the cube root. Now I've got x to the 7th. I'm going to break up that x to the 7th into x to the 3rd times x to the 3rd times x to the 1st. Because the cube root of x to the 3rd, it's just x. So those things are going to cancel each other out. X to the 1st. So 3 plus 1, that's x to the 7th. I took that 7 and I just broke it up. I'm going to do the same thing with the y's. Cube root of y cubed times the cube root of y cubed. 3 plus 3 is 6. I've got all those y's in there. At this point, what we want to do is just take the cube root of everything we can take the cube root of. The cube root of 125, over there, it's just 5. The cube root of x cubed, the cubed and the cube root, they cancel each other out, leaving us with just an x. And here's another x. So that means I've got x squared. I've got a cube root of x. I'm going to leave that for the end. But I've also got the cube root of y cubed, which is just y times y. Y times y is y squared. The only thing that's left underneath the cube root is this right here, that x. So the answer here, fully simplified, is 5x squared y squared times the cube root of x. That's the second 23. The last two I want to do are both inverse problems. Numbers 27 and 28. It says find the inverse of this function, and then identify the domain and range of the function and the inverse. This first one's a cubic. So the domain and range of the cubic, that's easy, because it's the same every time. It's all real numbers. So that's the domain and range of the original. To find the inverse, remember we switch the x and the y, and then we solve for y. So I'm going to start by adding 1 to both sides to get x plus 1 equals 2 times y minus 7 cubed. Now some people feel inclined to go ahead and take the cube root here. You don't want to do that. You want to get rid of the coefficient first by dividing by 2. Make that x plus 1 over 2 equals y minus 7 cubed. And you can leave it like that. If you prefer to write it as x over 2 plus 1 over 2, you can. But this form's a little bit simpler. So just leave it like that. The next thing we want to get rid of is the cube. And of course, the opposite of a cube is a cube root. So I'm going to take the cube root of both sides. Cube root of x plus 1 over 2 equals y minus 7. Well, there's only one step left here, and that's to add the 7 to both sides. That's going to be y equals the cube root of x plus 1 over 2 plus 7. And hopefully you recognize that as the cube root, which is a function every time. So you should write it in function notation. F inverse of x equals the cube root of x plus 1 over 2 plus 7. We're supposed to identify the domain and range of that as well. And hopefully you remember that the domain and range of the inverse is the same as the domain and range of the original, just flipped. In this case, they're both all real numbers, so both of these will be all real numbers as well. Number 28 is very similar. We do the exact same process. We're going to identify the domain and range, flip the x and the y, find the domain and range of the inverse. First, the domain and range of the original. This is a square root function, meaning that it normally starts at 0, 0. But you can see that it's been shifted to the right 2. And it's been reflected. And it's been pushed up 3. So the domain, you can kind of imagine, if you take it from 0, 0 and shifted it to the right 2, that means it's going to go from 2 to infinity. It's going to go from 2 all the way out forever. And if you don't believe me, you can graph that and see it. So it's going from 2 to infinity. Now the range has been pushed up 3, but it's also been reflected, which means it's going to go from negative infinity up to positive 3. And you should graph that to see it. The easiest way to get the domain and range right every single time is just to graph it. Take a look at it on your graphing calculator. So let's go ahead and find it. Let's do x equals negative square root of y minus 2 plus 3 to find the inverse. First step, subtract the 3. You've got x minus 3 equals the negative square root of y minus 2. At this point, you want to get rid of that negative by multiplying or dividing by negative 1. Doesn't matter. Get the same result. You end up with negative x plus 3 equals the square root of y minus 2. At this point, you want to square both sides to get rid of the square root. Don't worry about foiling that out. Just leave it like that. That's nice and pretty. You don't need to foil this out. Just leave it just like that. And the last step, add 2 to get negative x plus 3 squared plus 2. That's our inverse. That's a quadratic, so it is a function. Go ahead and write it in function notation. F inverse of x instead of a y. And the domain and range should be easy because it's the same as the original, just flipped. So the range here becomes the domain there. The domain there becomes the range there. So the domain is from negative infinity to 3. And the range is from 2 to infinity.